this slide is a little bit too busy. So what I'm going to do is I will erase at least some of what I just did on the board and recreate the slide on the board so that you find it slightly easier to interrupt me. Okay. So to start with, here's the floor. And let's say I have a some particle, and the particle is moving like that at some speed v. And let's say v is constant. Now, in this situation, if I want, I could ask the following question: what is the angular momentum of this particle? Now, you might say this is a weird question because the particle is not rotating. So what do I even mean? Angular momentum is for rotating things. At the same time, there should be an answer to this question, because how does the particle know at any given instant in time whether it happens to be part of something that is rotating? It has no idea. It's an inanimate object. So there has to be an answer. The point is that to figure out L, okay, to make this a meaningful question, I have to decide what is the axis. You see, angular momentum is defined with respect to an axis, so I have to make a choice. And to set it up the way that it is on the slide, let's say that the choice has been made, that the axis at the instant where I ask the question happens to be above the particle. So now I ask the question again, what is the angular momentum? Okay, well, let's set it up. So the angular momentum, L, is R cross P as a vector. So what is R? So R is this thing. Okay, it's a vector that points from the axis to the point you're talking about. And P is just MV. Okay? So, very good. So, in magnitude, this is R, M, V. And the direction of L, let's think about it. So, I take my right hand, I stick my pointer finger in the direction of the particle, I stick my middle finger in the direction of R, and my thumb will now point in the direction of the cross product. Wait, I did it wrong. 1 second. I'm supposed to put R in the direction. Sorry, my pointer finger should go in the direction of R. V is the direction of my. Wait, what? That you gotta like warm up for this class. Okay, so yeah, there we go. So now is R cross P, right? So R points down, V cross points that way, so P points that way. So my thumb points that way. I'm gonna need physical therapy after this. So so this is out. What the hell did I say up there? It's the same. Miracle. Okay, so you see what I did?
No.
Okay, I guess I'm getting old and this kind of feels weird, but whatever. So we're done, okay? We're almost done. So this question, not so bad, right? Once you think about it this way. But now let's complicate it, okay? So I'm gonna redraw it, and have no fear, the same information appears on the next slide. By the way, if I ever showed up to a physical therapist and said I injured myself during a physics lecture, which was purely theoretical, I'd probably never hear the end of it. Or maybe they would be telling all their friends later. They'd be professionals when they're talking to me, but. Okay, so, Now, a closely related problem. I keep my axis fixed. This is the axis. And now I ask, well, what if the particle is there? And it, it's still moving like that. So maybe this is a snapshot of what was happening before I asked that question. So now I could ask, what is L? So just so that it's easier for you to keep up with me, I'm going to show you. But I'm going to do it slowly, so don't be scared of all the equations here. So, well, what do we do to figure this out? So the first thing we do is we draw the radius vector. There it is, right? And then, I don't know, we start calculating, right? So the angle between the radius vector and the velocity vector is theta. Velocity points in the same way as velocity points in the same way as momentum. So what that means is L is R magnitude times, let me write it abstractly first. It is R cross P, same as before. Okay, but now R, the meaning of R is different. Let's work it out. So what is this? Okay. Let's call this length L. Let's call this length, this is the R vector. So I'm sorry, this is like weird notation, but let's say this length is L and this is R. So why am I doing that? It's because I want to write it in terms of the same quantities I used over here. Okay? If I do that, then this is L, M, V, so I'm going to write the magnitude, okay? Times sine of the angle between. Right? This angle. But this angle is sine of theta is R over L. So this is L, M, V times R over L. And look at this miracle. Do you see this miracle? In this picture, the symbol R means the same thing as it did over there if you view that as the transverse distance. Okay? That is not the distance from here to here, but the distance from the would-be, it's like, you like take the velocity vector and raise a perpendicular to the axis and measure that distance. If you think about it that way, okay, the formula for the angular momentum is that where R is the distance along a perpendicular connecting V to the axis. So I hope you see what I'm saying by that. So let me draw it. Here's V, here's the axis, here is R. This is the axis. So I take the vector V, extend it if I need to, take a perpendicular, measure this distance, that distance is R. Okay. Any questions about this? Yes, and then in the back, yes.
So because R is perpendicular to the V vector, does
Yes.
that mean that like in every single case it's going to be 90 degrees since it's perpendicular?
Yes, you could think of it that way, yes. And there's a question in the back.
On this side and last side, could you please show, like, with your pointer, which way I was directing on the screen?
Yes. Sorry, you mean on the screen? Okay, sorry. So I was doing this without looking at my screen. So the the R, okay, so R on the screen means the same thing as R on the board. I'm very sorry about the confusion. The little r vector is what I'm calling the R vector here. I'm sorry, that's very confusing. And L is the length of this thing. But of course, there's, what is written up there? Okay, so this is correct if you stare at it long enough. The length of R is L. The length of little r is L. And then it's consistent.
I meant like which way is out in the graph.
Oh, which way is out? It's pointing from the axis to the place where the velocity appears.
Okay.
Yeah. Thank you. Okay, I'm out of time, so I should shut up. But I hope you have a wonderful